Hi there, my name is Lauren Moss, and today I'm going to be talking about Experiment 1, Synthesis of Alum Crystals. Part 1 of our experiment involved synthesizing alum crystals from aluminum foil. We did this through a series of chemical reactions. We started off by placing aluminum foil in a strong solution of potassium hydroxide. The aluminum foil dissolved into aqueous aluminum hydroxide ions and produced a hydrogen gas. Then, we added a strong sulfuric acid to the solution containing these ions. At first, aluminum hydroxide precipitated out of solution, but gradually, this aluminum hydroxide dissolved back into the solution because the acid neutralized the basic aluminum hydroxide precipitate. Then, to make the alum precipitate out of this solution, we cooled it in an ice bath. By cooling the solution, we decreased the solubility of the alum to the extent that it was no longer soluble in solution, and it precipitated. Part 2 of our experiment involved recrystallizing our alum. We needed to use our solid alum to create a saturated alum solution. Before we made the solution, we rinsed the alum using a water-ethanol mix to remove any residual solution and dried the alum using vacuum filtration. When the alum was rinsed and dried, we masked it. We then calculated how much alum would be necessary to create a saturated solution at room temperature and added that amount of alum to the appropriate amount of water. Once we made the saturated solution, we put it in an uncapped vial covered by a Kim wipe, which would act as a filter. We knew that large alum crystals would grow with the slow evaporation of the solvent. As the amount of solvent decreases, the solute concentration increases and the solid will precipitate from solution because there's more solute than the solubility of the solution permits. Over the rest of the quarter, as the solvent slowly evaporates, we can observe the growth of the alum crystals in the vial. This experiment was conducted 5 days ago. Since the experiment, the vial containing our saturated alum solution has been resting on the windowsill in my dorm and the solvent has been evaporating. Let's take a look at the growth of the crystals so far. Along the bottom rim of the vial, on one side, there's a line of tiny crystals forming. From what I can see, the crystals look to be of uniform shape and size, cube-like and each less than a cubic millimeter large. The crystals seem to be growing slowly, but this is to be expected due to the fact that the solvent is evaporating slowly. If I were to try to grow crystals of table salt or NaCl, I would use a process very similar to the one that we use to synthesize our alum crystals. However, in this process, unlike the one we conducted in the lab, I would not need to synthesize the NaCl. NaCl, or table salt, is commercially available, and I could use this NaCl for my experiment. I would, however, need to calculate the solubility of NaCl in water at room temperature to determine how much NaCl I would need to create a saturated solution. According to a research report by Minneapolis Community and Technical College, to create a saturated solution of NaCl in water at 25 degrees Celsius, approximately room temperature, one would have to mix 37 grams of NaCl with 100 grams of water. Once I created my saturated solution, I would have to put it in a vial, cover the top of the vial with Kim wipe, and watch the crystals grow over time as the water evaporates. There are lots of ways to grow crystals, and that includes using different types of materials to make the crystals. According to an experimental study by Garrett and Rosenbaum of the American Potash and Chemical Corporation, instead of alum or NaCl, one could use borax to grow crystals. Sigma Aldrich, a chemical company, states on its website that borax is also known as sodium tetraborate decahydrate and is well known as a household laundry detergent. According to a research report by Nori, 2018, at room temperature, approximately 25 degrees Celsius, to create a saturated solution of borax in water, borax would have to make up 5.8% of the weight of the aqueous solution. One could use this information to calculate the amount of borax needed to create of a saturated solution of the desired quantity at room temperature. Then, one could pour the saturated solution into a vial covered with a Kim wipe. As the water evaporates, the borax crystals would slowly grow. That's all for now, but I'll check back in soon with more progress on the formation of my alum crystals.